We shall now begin with our discussions on time series analysis and forecasting methods. It has been our practice to collect the data over a long period of time. For example, we do the census every 10th year, that is, for example, we have the population figures for the year 1901, 1911, 1921 and so on up to 2011. And these data or this series of data is known as the time series data. That is, simply we call the time series. Now, these data can be used to forecast or to project the populations of the future years. Like looking at these data, doing some statistical analysis, we can project that what will be our population in the year 2021 or in the year 2031 or in between these years. So, we can see that the time series analysis and forecasting methods are useful for the government and as well as for the private players in making the decisions appropriately. So, in this lecture, we shall first discuss the various components of time series responsible for the variations present in time series data. We shall then discuss the mathematical models that relate the original observations and the components present in the time series. Forecasting or predicting is an essential tool in any decision making process. Its uses from determining inventory requirements for a local shoe store to estimating the annual sales of video games. The quality of the forecasts is strongly related to the information that can be extracted using past data. Time series analysis is quantitative method we use to determine patterns in data collected over time. Some other uses of time series analysis are to provide knowledge about the fluctuations in economic and business phenomena. The causes of changes can also be determined, though some fluctuations may take place under the same circumstances. It also helps to evaluate the achievements. Third, it is suitable for forecasting as well. The past trends can be projected into future trends to predict the changes which are likely to occur in the economic activity of trade cycle. As we have just discussed that if the population figures are given for last 10 or 20 years, then we can use this data to project the population for the coming years. Now, for example, look at this graph. These are the data pertaining to the sales of a particular commodity, and these sales figures are given from the year 1991 to 1997. So, this is a time series data or simply it is a time series, and if we plot these data, then we can see that there is a increasing trend in the sales of this particular commodity over the last few years. And by using some statistical devices, some statistical techniques, this information can be used to forecast the sales for the coming years. So, we have seen that we use the term time series to refer to any group of statistical information accumulated at regular intervals. There are four kinds of change or variation involved in time series data. That is, in a time series data, there are four different kinds of variation may present, maybe one of them or maybe two of them or maybe all of them may present in a time series. These changes are the secular trend, which we denote by capital T. The other one is cyclic variation, which we denote by letter C. The third one is the seasonal variation, which we denote by capital S, and the irregular variation, which is denoted by I. So, these are the four kinds of variation which may be present in time series. Now, what do we mean by the secular trend? With the first type of change, secular trend, the value of the variable tends to increase or decrease over a long period of time. The steady increase in the cost of living recorded by the consumer price index is an example of secular trend. We know that the consumer price index number has an increasing trend. It is go on increasing over the months or over the years to years. So, from year to individual year, the cost of living varies a great deal, but if we examine a long term period, we see that the trend is toward a steady increase, and this we can see that through this graph, that in this graph it shows that the data has an increasing trend over a period of time. The other examples of the secular trend or simply the trend are the data on production, sales, imports and exports, population employment, etc. have an increasing or decreasing tendency over periods of time. The second type of variation seen in a time series is cyclical fluctuation. The most common example of cyclical fluctuation is the business cycle. Over time, there are years when the business cycle hits a peak above the trend line. At other times, business activity is likely to slump, hitting a low point below the trend line. The time between hitting peaks or falling to low points is at least 1 year, and it can be as many as 15 or 20 years. The third kind of change in a time series data is seasonal variation. As we might expect from the name, seasonal variation involves patterns of change within a year that tend to be repeated from year to year. For example, a physician can expect a substantial increase in the number of flu cases every winter and of food poisoning every summer. Because these are regular patterns, they are useful in forecasting the future. The another example of seasonal variation is the sales of ready-made garments during the festivals, like during the Deepavali season or during the Christmas. The sales of ready-made garments just increases, and this phenomena is every year. So, this is an example of the seasonal variation. Lastly, the irregular variation. Irregular variation is the fourth type of change in time series analysis. In many situations, the value of a variable may be completely unpredictable, changing in a random manner. Irregular variations describe such moments. The effects of the Middle East conflict in 1973, the Iranian situation in 1979 to 1981, the collapse of OPEC in 1986, and the Iraqi situation in the year 1990 on gasoline prices are examples of irregular variations in the prices of the gasoline. Here these graphs shows the various types of trends present in the data. This shows the presence of the trend, that is the long term changes in the data. In this case, the seasonal variation, where on the x axis we takes the months and on the y axis the quantity. So, we can see that how a graph will show if the seasonal variation will be present in the given data, and this is a graph of the cyclical fluctuations present in a time series. So, we see through these graphs and otherwise that the time period of the secular trend, it is a long term change present in the data. So, the period of change is normally more than a year, and also in case of the cyclical fluctuations, the change of period may be from 1 year to maybe up to 15 years or 20 years, but the variations present in the seasonal variation will be less than a year, it may be months or it may be the days. So, once we plot the time series data on the graph, we will have an idea that what types of variations are present in a given time series. Then our next step is to analyze these data, and for that we use some mathematical models. There are different types of mathematical models which we are now going to discuss. The first is the additive model, then the multiplicative model and the model given in the C. That is, the time series data is assumed to consist of a mixture of some or all of the following 4 components, namely the trend, cyclic fluctuations, seasonal variations and irregular variations. That is, in a time series either all the 4 variations are present or a few of them. So, in case of the additive model, the yt, that is the yt is the observed value of the variable under study at time t, and this yt we assumed under the additive model is equals to the tt plus st plus ct plus it, where this t, s, c and I, as we know, denote the secular, seasonal, cyclical and irregular variations. And in the multiplicative model, this yt is equal to the product of all these 4 components. And in the third model, this yt is equals to the product of these 3 components, that is tt, st and ct plus it, and this is for different values of t, which takes the values 1, 2, 3 and so on. So, our problem is to isolate these different variations, and using this model we study the information present in the data for the purpose of forecasting or taking some decision on the basis of these analysis. The multiplicative model B gives, that is, when we take the logarithm on both the sides of the multiplicative model, then it gives the log of yt is equals to log of tt plus log of st plus log of ct plus log of it. That is, logarithm of the original data can be modified by a pure additive model. And we also note here that distribution of it often tends to be highly skewed, but however, log of it tends to normal distribution approximately. That is, when we take the logarithm of the irregular component, then its distribution is normal. In most of the situations, the multiplicative model is appropriate for the use, but it will be advisable to use additive model provided some features as given here are not noticed. Number 1, 4 components of time series are not influencing each other. That is, the 4 components, that is the secular trend, cyclic fluctuations, seasonal variations and irregular variations, they do not influence each other. The second one is the seasonal variations remain fixed in spite of the growth or decline in the trend. Since there are hardly any ways to detect such situations in which the additive model can be used, we will confine ourselves to multiplicative model only. But before we use any model or any type of statistical analysis of the time series, it is suggestive to edit the data. That is, before we use the data for analysis, it needs initial examination. Mainly following type of adjustments are needed. The first one is the price variations, second population changes, third units of measurement, and the last one is calendar variations. Price variation. The sales of a business organization, if expressed only in monetary terms, will mislead the management. Similarly, if we assess the production merely in terms of returns, it will be highly misleading. So, we make the following adjustments in the given data. That is, the given data are changed to quantity, that is, when the data on the sales and price per unit are given, we change these data by using this simple formula that the Q is equals to V divided by the P. Here the Q, V and P denote the quantity, value and the price per unit of sales or production in a specified period. In population changes, the consumption of cloth, sugar and food grains etc. totally depend on the number of consumers. The more of the population, the greater will be the consumption. Hence, it is necessary that the consumption be calculated on the basis of per capita or per thousand people in order to have a clear picture of the time series data. Sometimes units of measurements do get changed over a period of time. For example, earlier the units seers, yards and miles have been changed to kilogram, meter and kilometer respectively. Therefore, to compare the old figures with the new one, the data should be changed into the same units of measurement. So, these are the main points one should look at while editing the data, but there may be some more ways to look at the data and edit it before you start making your analysis, either using the models or some other statistical techniques which we are going to discuss in my upcoming lectures. Today we have started our discussions on analysis of time series and forecasting methods. And we have seen that there may be 4 kinds of variations present in a time series. These are secular trend, cyclical fluctuations, seasonal variations and irregular variations. Now, the problem is how to study or how to measure these different types of variations present in a given time series. Because once we study or once we measure these types of variations present in the data, then we can use these data for the forecasting purposes. We then have discussed some mathematical models to be used for the mathematical analysis of the given data. And once we analyze these data through the mathematical models, then we can make use this information for the purpose of forecasting. And such forecasting methods are not only useful for the government bodies, but they are also useful for the private players. Thank you.